Hi, welcome to video 6.7 on graphing quadratic equations. So some of this is going to be review and some of it's going to be new. We're going to kind of use what we already know to help us do some graphing of quadratic functions. So our standard form is ax squared plus bx plus c, and a, b, and c are just numbers, constants. The shape of a quadratic equation is called a parabola. That's that arch shape. And so we've got our parabola right here. Parabolas are symmetric through a line creatively called the axis of symmetry. And I'm not going to write it again, but that right there, axis of symmetry. And then our highest or lowest point is called the vertex. So same thing, that's the vertex right there. It can also be called a maximum or minimum depending on what it is, and we'll talk a little bit more about that later. Okay, on this one, just by looking at this, we're going to figure out what the vertex, axis of symmetry, and y-intercept are. So the vertex is going to be our maximum or minimum, like that right there on this one. So our vertex is going to be 2, -2. And then our axis of symmetry is going to be right where if I folded it in half, it would look the same on both sides. And this line is x equals 2. When we have a vertical line like that, it's always going to be x equals whatever, because at every point along here, like this point would be 2, 1, 2, 2, 2, 3, 2, -1, whatever. The x would be 2 for all of them. So x equals 2, and then our y-intercept is where it hits the y-axis, and so that's going to be 0, 2. Okay, for the next one, you go ahead and try to find the vertex, axis of symmetry, and intercept. So go ahead and pause it. All right, hopefully you've already done that, and here's your answers for those. Okay, so flip the page and let's take a look at some other things that we need to know. So, important information. This leading coefficient that was really important before is still important. If A is positive, then our parabola goes like this, and if A is negative, then our parabola opens downward like that. So this one, if it is negative, is going to be going like that, and so it has a maximum, and it is because A is negative. This one is going to be the opposite. This one's going to have a minimum because our graph is going to look like that, and it's because A is positive. Okay, so our solutions. We spent like an entire chapter, all of Unit 5, solving quadratic equations. And one of the reasons why that's important is because the solutions tell us some things about the way the graph looks and the way that the parabola behaves. So our solutions are the x-intercepts, because we put in 0 for y, and all along our x-axis y equals 0. Other words for solutions to quadratic equations, they can also be called roots, or they can be called zeros. Okay, moving on, let's actually do some graphing, some trial and some practice. Okay, so this is what we did in chapter 5. We did factoring. So I'm going to do a factor sums table, and I am looking for factors of 15, and I want them to add up to -8. The first ones I think of are 3 and 5. Those add up to 8, but -3 and -5 add up to -8. And if you can factor, if you're getting good enough at factoring that you don't need to make this, that is fine and great, and you do not have to. So I'm going to do x minus 3 and x minus 5 and equal to 0. The reason we're saying it's equal to 0 is because we want our roots, our x-intercepts, and all along our x-axis, y equals 0. So if I put 0 in for y, that's going to tell me what my answers are. So this, if I make x minus 3 equal to 0, it's 3, and then x minus 5 equal to 0, my answer is 5. So over here, when I'm graphing my parabola, I'm going to put the x-intercept of 3 and the x-intercept of 5 like that. No, I counted wrong. Sorry. Okay, so this is 3, 4, 5. Okay, now that's right. And then now we're going to do the vertex. So the vertex is always going to be exactly in the middle of our parabola. So our vertex is going to be going down the middle. And I'm actually drawing the line of symmetry because that's going to help me. So our vertex is going to be in the middle of 3 and 5. And what's in the middle of 3 and 5? 4. So 4 is going to be my x coordinate for my vertex. And what I'm going to do is substitute this 4 into my original equation, and then I'm going to solve for y, and that will tell me the y coordinate of my vertex. So I have y equals x squared minus 8x plus 15, and then I'm going to substitute. So instead of x, I'm going to put in 4 minus 8, 4 plus 15. So now I have 16 minus 32 plus 15. Negative 16 plus 15 gives me negative 1. So my y is equal to negative 1. So that means I have 4, negative 1, and that's going to be my vertex. So we know it's going to look like that. My axis of symmetry is at x equals 4. Okay, now it doesn't tell us to on this, but I'm going to use my y-intercept as well because this is like we're only seeing a tiny little portion of this. So for my y-intercept all along the y-axis, x equals 0. So if I put 0 into my x's here, that zeroes out, that zeroes out, I still have plus 15. So that means that when my x is 0, y equals 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my 15 is going to be up here, and it's symmetrical, so that means on the other side, that was 1, 2, 3 away, so 1, 2, 3 away, I'm going to have an identical point over here, and so my parabola is going to look like that. And we can't really use a ruler to make this better, we just have to kind of do a good job, and you should probably use a pencil unlike I'm doing so that you can erase and make it look nice. Okay, let's try another one. Okay, so we're going to factor. One thing we still need to look out for when we're factoring is if we have a GCF. So notice we've got 2 divisible by 2 divisible by 2. So I can factor out, I'm going to factor out a negative 2 because that's going to leave me just with plain x squared. Negative 4 divided by negative 2 is positive 2, so that's positive 2x, and then positive 6 divided by negative 2 is negative 3. So I'm going to change that to 0 because I'm looking for my x-intercepts here, equals negative 2, and then I know it's going to look like that. My factors of 3 are 1 and 3, and then I want them to add up to positive 2, so that means I'm going to do plus 3 and minus 1. If you want to do a factor sums table, it looks like this. So your factors are factors of negative 3, and then your sum is going to be positive 2. Okay, now if I set negative 2 equal to 0, that's not possible, so that's not going to help me with my roots. If I put x plus 3 equal to 0, I get negative 3, so that's one of my roots. And if I put x minus 1 equal to 0, I get 1. So that's a root. So 1, 2, 3, that's my first one, and then 1 is the other one right there. Okay, so my vertex is going to be right in the middle of those. So right in the middle of negative 3 and 1 is going to be negative 1. And then I'm going to put that into my equation up here. So negative 2, negative 1 squared minus 4, negative 1 plus 6. So negative 2 times negative 1 times negative 1 is positive 1. So that's going to be negative 2. Negative times a negative is positive, plus 6. That's going to be 2 plus 6 gives me 8. So my y coordinate is going to be 8. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8. And this makes sense because I know it's going to open downwards since I started out with a negative 2. My axis of symmetry, right down the middle here, that's going to be negative 1. And if I want to, I can find my y-intercept just to give me another point to go with. If I put zeros in for x, I'm going to end up with positive 6. So there's that. And then on the other side, I'm going to have a symmetrical one. So that is what my parabola looks like. All right, go ahead and flip over. All right, I'm going to do one of these and you're going to do one, and this one I'm going to leave for you because it's a little bit easier and fractions scare people. So I'll do the one with fractions and you can follow along and then you can try the other one. Okay, so our roots or zeros, they already give them to us. It's 3/4 and -1/4. Our original quadratic function, we're just going to multiply these together. So if I want 3/4 to be a 0, then -3/4, x plus 1/4, because if I put -1/4 in here, it would be a 0. Now I just multiply x times x is x squared. -3/4 times x is -3/4 x. X times positive 1/4 is positive 1/4 x. -3/4 times positive 1/4 is -3/16. So now I have x squared minus 1/2 x minus 3/16 equals 0. And my vertex is going to be directly in between those. So if I have 3/4 and -1/4, that's going to be halfway in between there is going to be 1/4. So like right there. So 1/4. So now I'm going to put 1/4 into this equation. So I've got 1/4 squared minus 1/2 times 1/4 minus 3/16. So 1/4 times 1/4 is 1/16. Multiply those together and I get minus 1/8. And then I have minus 3/16. And so then this is the same thing as 2/16. So I'm going to change that to 2/16. 1/16 minus 2/16 is -1/16. Get -4/16, which is the same thing as -1/4. So -1/4. So our point is positive 1/4, -1/4, right there. My axis of symmetry is going to be in the same place. It's going to be at 1/4, my x value of my vertex. And then I don't really have anything else to help me on this. My y-intercept doesn't help me a lot, so I'm just going to draw with what I've got. Okay, you try the one at the top, pause the video, and come back and take a look at my answers. Okay, here are your answers. So roots, -0.5, -6.25, and then -0.5 or -1/2, whichever you want. Okay, I am going to save the graphing calculator problem for another video because I'm almost running out of time.